Hello all and welcome to the Math 8 video for what we're going to call square root equations. Now with these equations, as you'll notice when we look at some of the examples, they actually don't have square roots in them. I'm calling them square root equations in that what you're going to have to use to solve the equations, or the inverse operation, as you see here, that you're going to have to use to solve the equations, is the square root. Okay, so what I mean by this are equations you solve by using the square root. So, like I said, in this case, it's kind of a misnomer in a bit in terms of square root equations. It's kind of a weird name in that there's no square roots in the equations, but you use equations to solve these, or you use square roots to solve these equations. Okay. So with that being said, we do have a new inverse operation we have to talk about. So when we talk about inverse operations, okay, those are the things we talked about before with equations where, okay, addition, well, the inverse operation of addition is subtraction. Same thing vice versa, meaning subtraction, the inverse operation of subtraction is addition. And then you also have multiplication, which the inverse operation is division, and division, where the inverse operation is multiplication. So we're adding a new one to this. So in this case, if you have something that's squared, meaning, so just a little note here, and you can write this on your paper if you like there, to just let you know what we mean when we say squared. Okay, this means you have the exponent of 2. Okay, so that looks something like x squared. Okay, so that's what I mean when I say squared, is you have an exponent of 2. So you're raising the variable to the exponent of 2. Now, with that being said, that's an operation, okay? So if you think of PEMDAS, well, what's the E in PEMDAS stand for? Well, that stands for exponents. As we'll see here in just a bit, I'll make a reference to PEMDAS so you can see exactly where this fits into our order of operations. So if something's squared, well, the inverse operation of that is to take the square root, okay? So if we remember, the square root is this funky looking symbol here where you do something, so you take like the square root of 4, okay? If you remember what that means, well, what number times itself equals 4? Well, in this case, that would be 2. Okay, so that's what I mean when we're taking square roots, okay? And then vice versa, and this is something you'll learn as you go on through math is, well, if you have square roots, well, how can you get rid of square roots? Or how can you solve an equation involving square roots? Well, you can square things, so you can raise things to the second power. But that's something we're not worried about today. We're mainly worried about this direction, meaning, okay, if we have something that's squared, how can we get rid of the exponent of 2? Well, we can do that by taking the square root. And that's what we mean by inverse operation here, okay? The big thing with this, and I'll reference this many times as we look through the examples, these equations can have more than one solution. And in all honesty, every single one of these equations will have 2 solutions, except, and you'll see there's a special case where these types of equations can only have 1 solution, okay? But I'll go ahead and tell you most of these equations will have 2 solutions, so that's definitely more than 1 solution, okay? Now the steps here, kind of got them squished at the bottom here because I'm not too interested in writing out the steps like this. I really do think more people would see better by looking at the examples. But if you notice, the same as always with these last few sections with equations is the first and the fourth step are exactly the same, meaning first thing you need to do is locate the variable you're even solving for, okay? In this case, it could be an x, it could be an m, it could be a y, a t, an a. Once again, could be anything, any variable that you see in the equation. That's the variable that you need to solve for. On top of that, the last step here is check your solutions. So just like with any equation, you get an answer, you can plug it back into your equation and make sure that it works, make sure that it's true, okay? Now the 2 in the middle, the 2 steps in the middle, so steps 2 and step 3, these are where these kind of equations become a little bit different. So the second step here, you see it says to isolate, and in quotation marks here, I've got x squared, because most of the time when we see a variable in algebra, we see it as an x, so we say x squared, okay? But I put that in quotations here to say, well, whatever it is in terms of, like, it could be m squared, it could be t squared, it could be y squared, it could be p squared, okay? Could be whatever variable you can think of. In this case, it's kind of a placeholder saying the variable squared, and then you just use the inverse operations we know from before. So adding, subtracting, multiplying, dividing, depending on what you're doing in the equation, okay? And then the last step to get the solution is to take the square root of both sides, okay? So just like before, if we needed to divide both sides, well, we divided both sides. Well, in this case, take the square root of both sides means we're doing the inverse operation of squaring. So in this case, instead of squaring, we need to square root. So that means we need to do it to both sides, because to remind you, these are still equations, okay? So if you do something to one side, you've got to do it to the other, okay? So with that being said, that's pretty much it in terms of the steps. Now, let's go ahead and look at some examples, and the rest of this section is just pretty much examples. So if you pay attention and look at how I explain how to do these examples, it should explain how we use square roots in equations very easily here, okay? So let's go ahead and jump into number one. So I'll go ahead and tell you the first 6 questions here are very super easy, because these are what we would consider one-step square root equations, meaning there's only one thing we have to do in these equations. And as you can probably see, these are very simple in that, what do we have here? So number one, we have x squared. Well, if we look at our steps, well, x squared is already isolated on this side. That's all that's on this side of the equation. Once again, we're talking about sides of the equation just like this, okay? But in this case, we really only have to do one thing, okay? And that is indicated by, okay, well, we have x, we're squaring it, so we have x to the exponent of 2. Well, how do we get rid of this exponent of 2? Well, this is where the square root comes in. And this whole point in taking the square root is the exponent goes away, the square root goes away. So all you're going to be left with is x, which is our goal with pretty much any equation that we try to solve. We want to get the variable by itself, okay? But here's the deal. If we square root this side, we've got to square root the other side, okay? So in this case, square root of 36, we're asking what number times itself gives you 36. And everybody, if you know your times tables, would probably say the answer here is 6. And I will say you would be correct for one of the answers. But if you remember talking just a second ago, these equations can have more than one solution. And I gave you a big hint saying all these equations should pretty much have 2 solutions. And this is where these kind of equations kind of get a little tricky, so you got to really pay attention here. It's not only 6 you can multiply it by itself to get 36, but you can also multiply -6 times itself and get 36. And the whole reason this is because a negative times a negative equals a positive. So 6 squared is 36, but also -6 squared is 36. So we actually have 2 different answers here, 6 and -6. And you'll kind of see a pattern with these in that the answers to all these questions are either the positive or the negative of whatever number you calculate. Meaning square root of 36 is 6, well, that means -6 has to be an answer. And that goes straight back to the fact that when you square something, that means you multiply it times itself. So the 2 numbers that you can multiply times themselves are 6 and -6, because both of those give you positive 36 as an answer, okay? Now, we do have special notation, and from here on out, this is what you'll see me use. Instead of having to write out the answers like this, 6 and -6, we could simply say x is equal to, and we have this special symbol that we can use. And it looks kind of silly because it's a plus sign, over top of a minus sign, okay? So it's kind of both a plus and a minus in front of a 6. And all this notation means is instead of having to write out both 6 and negative 6, this right here tells you all you need to know, in that it tells you x is equal to positive 6 and negative 6. So you can kind of shorten up your answers a little bit by just using this little symbol right here, which means positive and negative. So we call this the plus minus symbol. So plus or minus 6, which once again means positive 6, negative 6. Okay? Same thing with number 2. Things are kind of flipped around here. So if we absolutely had to, just so it's the same way, we could just flip across the equal sign, no problem. Now, is this necessary? Not really. But if it helps you see what's going on, we can see the sides of the equation. Well, y squared is equal to 289. We need to get rid of the squared. So in this case, we need to square root it. Square root this side. Same thing. On this side, on the left side, we get y, because square and square root are inverses, meaning if you square something and then square root it, it kind of cancels the square out. So in this case, or the exponent of 2 out. So you just get y here, which is our goal with any of these equations. But we can kind of use our knowledge about the notation here, and this one's a little tricky, but this is where, if you absolutely had to, you can use your calculator. But this is something that I'm pretty sure most 7th graders learn in terms of all the perfect squares up to 400. So if you know that from that list of numbers, that's awesome. That's great. But we'll say that the easiest thing to do here is, if you absolutely had no idea what the square root of 289 is, you can plug it into the calculator. Square root of 289, well, that is 17. But from what we said over here, well, it's not just 17, it's also negative 17. So instead of writing both 17 and negative 17, I'm simply going to use this symbol, plus or minus. Okay, so the answer to that equation is positive 17 and negative 17. Okay, so both of those actually work for that equation. Number 3, same kind of thing here. M squared is equal to 121, so what could M be? Well, if you know your times tables, this should be pretty easy, because we would take the square root. We get M is equal to, because those two cancel out, M is equal to, well, if you know your times tables, we know 11 times 11 is 121. But once again, if you have trouble with that, by all means, I would much rather you double check yourself with a calculator than guess and get the wrong number. Okay, so in this case, square root of 121 is 11, but we got to remember, as you see, there's kind of a pattern going on here. Square root of 36 was 6, so we had negative 6. Square root of 289 is 17, so we had negative 17. Square root of 121 is 11, but we also have negative 11. Okay? Every single one of these has two answers, the positive and the negative of the number that you calculate. Okay? Except for one, and we're actually getting ready to go over that one here in just a second after we do number 4. So same thing here. I'm not going to turn this one around though, okay, like I did number 2. So you can do that. You can remove the k squared over here is equal to 400. But all you got to recognize here is we got the variable squared. So we need to square root. So what's going to happen here? We get k squared square rooted. So that just gives us k. Well, square root of 400. This is actually pretty easy. If you're clever about it, it's actually a pretty easy thing to think about. So what number times itself equals 400? Well, that's actually 20. Okay, but once again, if you need trouble with the bigger numbers like that, that aren't necessarily on your times tables, this is a super easy process to do on your Desmos, specifically Desmos calculator. Now, if you're using a phone calculator or a handheld calculator, it might be a little more difficult because you might need to find where the square root button is. But on the calculator we've been using all year, the Desmos calculator, it's literally right there in front of you. You can click the square root button and you can do the square root of 400. But we have to remember, and this is the thing, the calculator will not tell us this, is that if you take the square root of 400 here, yes, what the calculator gives you is 20, But you also got to just know, okay, and this is something that you just at this point have to know, okay, is that you also have negative 20, because it all goes back to the fact positive 20 times positive 20 is positive 400, but also negative 20 times negative 20, since a negative times a negative is a positive, negative 20 squared is also 400. Okay? And then we get to a special case. And it's actually a really super easy special case in that we have a squared is equal to 0. Well, if we do things as normal, we take the square root, we get a on this side. It's kind of maybe a little harder to think about here, but the square root of 0 is actually 0, because 0 times 0 is 0. So if you take the square root of 0, that's just 0. But in this case, we don't have two answers. We just have the answer is just 0. Okay? And you might be asking, well, why do all the rest of them have an answer, two answers, but this one only has one? Well, it goes back to the fact that 0 is neither positive or negative. So it's neither positive nor negative, meaning there's no such thing as a positive 0, so that means there's no such thing as a negative 0. So 0 is kind of just 0, and in that case, like I said, it wouldn't make much sense to put plus or minus in front of 0, because there is no such thing as a negative 0. There is no such thing as a positive 0. So in this case, a little note you can put here, because that's actually the whole equation here, is take the square root of 0 at 0, and this is because it'd be nice if I could spell, there are no negative 0 or positive 0. Okay, so there's no negative 0 or positive 0. So once again, it doesn't make sense to say negatives and positive 0. It's just 0. And then the last one of the what we would consider one-step square root equations here is we get r squared is equal to 196. Same thing. Take the square root. R squared is equal to square root of 196. Once again, not one that's on your times tables, but if you remember all the perfect squares, this is the perfect square where 14 times 14 is 196. But at the same time, once again, you can double check that. And the calculator is just going to give you positive 14, but you have to know negative 14 is also an answer. Okay, so now we're going to get into some harder ones, starting with number 7. Okay, so up to number 6, those are all basic square root equations, meaning there was only one step. So these are technically one-step square root equations. So the next logical step to do is let's go to two-step square root equation. So if we look at number 7, we have x squared minus 10 is equal to 39. And this is where, so I'm going to use the bottom of this box right here, just so we can see. So this is where this kind of comes into play. We have to follow, just like any other equation, we have to still follow order of operations. Meaning, if we have x here, well, what are we doing to x? We're squaring it, then subtracting 10. Okay, because in order of operations, exponents come before subtraction. So that's what the E in PEMDAS stands for, are these exponents. So we have to raise x to the second power, then we can subtract 10. So that means, once again, if we're working backwards with order of operations, that means we have to take care of the subtraction first, then we can take care of the exponent. Meaning, we have to add 10 first, then take the square root. And it has to be in that order. If you try to take the square root first, that's not going to work out for you. And once again, same things hold for all our previous equations. We add 10 to both sides. The 10's here will cancel. X squared is equal to 39 plus 10 is 49. And now we have essentially what we had before, a one-step equation where the last step is to take the square root. So we get x is equal to, this is definitely one everybody should know from your times tables, What number times itself equals 49? Well, that is 7. And -7. Okay. Like I said, all of these are going to have two answers, the positive and the negative of whatever number you calculate, except when that number is 0. Okay. So if we look at number 8, let's speed this up a little bit. Same kind of thing. We have m squared plus 24 is equal to 33. Well, exponent would be squared. So in this case, we would square m, then add 24. So that means if we're going backwards, okay, so we got to always remember we're working backwards when we solve an equation. That means we need to subtract 24, then we can take the square root. So subtract 24. So the whole point here is those go away. We get m squared is equal to 33 minus 24 is 9. And then, once again, always the last step here with these types of equations is take the square root. So we get m is equal to, well, once again, easy one if you know your times tables. What number times itself equals 9? Well, that is 3 and -3. Okay. If you just give me 3, you're only giving me half the answer. So if you think about it, that should only garner half credit on an answer, which most likely I would give you more than that. But we got to really remember, okay, that if you take the square root of a number, okay, in this case, in an equation like this, if you take the square root of a number, you got to look back and think about what it's really saying. It's telling you, okay, this number squared is equal to 196 for number 6. Well, there's actually two numbers that when you square them or you multiply them times themselves, they give you 196, and that's both positive 14 and negative 14. So that's why every single one of these equations has two answers besides one like number 5. Okay? So number 9, same kind of thing here, but we've really got to pay attention. Okay? So I'm going to write it up here just so we can have it. And this is something, it does not hurt anytime you have a question on a paper, especially like when you're testing as far as SOLs or any type of test that you're doing. It doesn't hurt to write PEMDAS at the top of your paper, because a lot of things in math, you really got to know order of operations, especially when you're solving equations. Because if you look here, we've got 192 is equal to 3 times w squared. So we got the 3 directly next to the w. But here's where we got to pay attention. The exponent is the squared. Well, what's being squared? Well, if you remember when we talked about exponents, or if you've ever talked about exponents before, it's common knowledge that the square here, the exponent, is only being raised to the w. Okay? If it was also being raised to the 3, you would see parentheses around the 3w, meaning you would have 3w squared. You would have 3w times 3w. But in this case, you only have w squared. Okay? So in this case, we have to follow order of operations. So exponents come before multiplication. That means when we're solving, division has to come before square root. So the first step here is actually we need to divide by 3. Since our last step in order of operations is multiply by 3, our first step in solving the equation is to divide by 3. This one's kind of a little tricky here. 192 divided by 3. That's a little tricky. Okay. Bigger numbers there, so if you need to, definitely double check yourself on a calculator, or you can go off to the side and actually do some old school long division. But if you do that, you'll actually see that that number is 64. But the whole point here is the 3's will go away, so we have w squared. Well, the last step, as with all of these, is we've taken care of the multiplication. Now we can take care of the square, so we can take care of the exponent. So we get w is equal to, or in this case, something's equal to w. Well, if you know your times tables, this is yet another easy one. 64, the square root of 64 is 8 and -8. Okay. Number 10, just the opposite of number 9. You have k squared Then you're dividing by -5. Once again, exponent comes before division, okay? And that's equal to -20. Well, if we're going backwards, that means the first step here is we need to multiply by -5 first. Because once again, if you're working backwards, multiplication comes before exponents. So in this case, we get k squared is equal to, in this case, negative times a negative is a positive. 20 times 5 is 100. Okay. And as always, the last step with these is take the square root. So we get k is equal to, this was actually probably, besides maybe 0 or 4, or 1 even, so 1's a pretty easy square root. This is probably one of the easier square roots everybody remembers. What times itself equals 100? Well, that's 10, but also -10. So like I said, just be aware that all of these have two answers except if the answer is 0. Okay? So number 11 here, same kind of thing. P squared plus 52. This one's actually going to work almost exactly like number 8 here. We're adding 52 to p squared. So once again, exponent, do p squared, and then we would add 52. So working backwards, that means we need to do the opposite of addition. So we need to subtract 52, then take the square root in that order. So subtract 52. Boom. P squared is equal to, this is kind of difficult, but if you really think about it, you can go over here and actually do 341 minus 52, the old long way there. Make this 11, borrow 1, make this 13, borrow 1. So in this case, it's going to be 289. Okay, but same thing here. After you do that calculation, the last step is take the square root, because we always want to get rid of the square there, the exponent. So we get p. Well, we've already know what the square root of 289 is based on number 2. We know that it's both positive and negative 17. Okay, because once again, if you look at the equation, p squared needs to be 289. Well, there's actually two different numbers you can multiply times itself to give you 289. And let's see, look at number 12 here. Very similar to number 10, except for instead of dividing m squared by -5, we're dividing m squared by -2 or by +2. So in this case, m squared divided by 2 means you multiply by 2, take the square root in that order. So multiply times 2. Take the square root. And this is another one that everybody should know from your times tables, because this was the biggest number that was on your 12 by 12 times tables, which is 12. Okay, so m equals positive and negative 12. And number 13, this one's kind of a tricky one, but you can use the same little trick here that we've used on a lot of other equations, in that, all right, we have negative p squared. Well, technically, since there's not a number in front of p, we can put a 1. So technically, we have -1 p squared. So if you look at that compared to number 9, well, we have -1 times p squared. Well, that looks very similar to 3 times w squared. So what did we do there? We divided by 3. So we're going to divide here by -1. But if we do it to one side, we got to do it to the other. So we get p squared is equal to negative over negative is a positive. 324 over 1 is just positive 324. So as always, the last step is square root. So we get p is equal to square root of 324. Another kind of tough one here. It's hard to think about, but it's actually 18. But then like I said, with these being equations, both positive and negative 18 work. So like I said, in these cases, know that you're going to always get two answers. Sound like a broken record. You always get two answers unless your answer is 0. Now, with the next three equations, once again, we kind of ratchet up the difficulty a little bit here in that the answers that you should get for numbers 14, 15, and 16 should all be fractions. A lot of people would probably go through and do the steps here, but end up getting a decimal at the end, which if you convert fractions into decimals, I mean, you could possibly get a decimal, okay? But the point of these questions are, how do you take the square root of a fraction? And it's actually might sound hard because we're talking square roots. Now we're going to talk fractions, which I know everybody hates fractions, okay? But in this case, it's actually really easy, okay? So if we look at number 14, looks very similar to number 9, except for kind of flipped around there. So we can see, and kind of like number 13 here, our first step should be to divide by 4. Whole point here is those go away, so we get x squared. Okay, both sides. So we got to do it to both sides. But then we do 9 divided by 4. And if you actually plug that in a calculator or you do that division, you actually get the fraction 2.25. Okay. But I'm not going to write 2.25 here. I'm going to leave 9 divided by 4 as the fraction 9 over 4. And you might think, well, why? We've still got to take the square root because that's going to be the next step is to take the square root. Well, you can still take the square root. And actually taking the square root of a fraction like this is really easy. All you've got to do is if you take the square root of a fraction is you take the square root of the top and divide it by or put it over the square root of the bottom. Meaning, what's the square root of 9? Well, that's 3. What's the square root of 4? That's 2. And then the last step is to remember we have both the positive and the negative. And you can verify this if you like to. Once again, what did we say when we got 9 over 4? So 9 divided by 4, well, that's 2.25. If you want to, take the square root of 2.25 in your calculator. I guarantee you're going to get 1.5, which 1.5 as a fraction is the improper fraction 3 halves. Okay. But then, like I said, our knowledge of what we talked about just before has to kick in and say, oh, well, we just took the square root, so it's not only positive 3 halves or positive 1.5, it's also negative 1.5 or 3 halves. But I will be looking, so for on homeworks and stuff, the whole point in this type of question is, how do you take the square root of a fraction? Well, this is how you do it. You take the square root of the numerator and put it over the square root of the denominator. So it's the same thing with number 15. Number 15, you can see the similarities here. 81n squared is equal to 16, so that means we need to divide by 81. So we get n squared is equal to, well, once again, in this case, it's actually a pretty nasty decimal, okay? You plug that in, you get this nasty repeating decimal that actually, if you, depending on the calculator you're using, actually doesn't seem like it's repeating too much. So just to get the exact number here, let me take that square root. So we take the square root of, so we have 16 divided by 81. Okay, that's the decimal. 16 divided by 81. That's the decimal 0.197530864. And that actually, somewhere down the line, that actually repeats. So depending on your calculator, it's actually not going to show you that repeats. But regardless, that's a nasty long decimal that you're going to have a hard time taking the square root of if you try to do that in a calculator. But the point here is we don't have to do that. Let's leave this as the fraction, 16 over 81. And now let's do what we know how to take, so that we know how to take care of a fraction now. Square root of 16 is 4. Square root of 81 is 9. So my answer here is actually both positive and negative 4/9. And if you were able to manipulate your calculator enough, you can actually leave that answer in there and take the square root of it. Well, you will see that it's 0.4444444444444. And then in that case, that is the fraction 4/9. Okay. But like I said, I'm going to be looking for fractions on these answers. So just to let it be known, okay, if you give me the decimal, you will not get full credit. Okay. Because like I said, the whole point in these types of questions. So number 14. So if you want to star these, just so you know, okay, so you don't mistake them and don't do what I ask you to do here, is on these, I would like to see fraction answers, meaning if you get a fraction here and it turns out to be a nasty decimal, okay, or something that doesn't work out very nicely, then you can still take the square root of it. It's just you got to take the square root of the numerator over the square root of the denominator. So square root of 16 is 4, square root of 81 is 9. So our answer is 4/9. Now number 16, same exact thing. Just one little hiccup on this one, though, is that we have negative 25q squared is equal to negative 49. So same things here. We're going to divide by negative 25, just like same step that we did in numbers 14 and 15. We divide by whatever multiplying times q squared here. The point here is those will go away, so we get q squared is equal to negative 49 over negative 25. Well, we can actually go ahead and say that the negatives are going to cancel out anyway, but it's the same kind of thing here. You get a fraction that doesn't really work out too nicely. We get 49 divided by 25. It's actually 1.96. And from here, once again, you could definitely take 1.96 and do the square root, okay? But in this case, that's not what I'm asking you to do, because if you can take this, you can see, well, that's going to be a decimal, so let's leave it as 49 over 25. Let's leave it as a mixed number, or as a improper fraction. So now let's take the square root. The whole point there is to get rid of the squared, so q is equal to square root of 49 is 7 over square root of 25 is 5. Okay, so our answer is actually positive 7/5 and negative 7/5. But this all goes back to, if you have a fraction, okay, don't run automatically and try to use the decimals, because sometimes those decimals, as in the case with number 15, those decimals can be pretty nasty. Okay, so in a lot of ways, you can kind of think of it. I think it's actually kind of easier to take the square root of a fraction like this than to try to get the decimal and then try to type in a decimal and take the square root of a decimal. Okay, so like I said, the whole point with these three questions is to give a fraction answer by taking the square root of a fraction. And just to give you a hint, numbers 10, 11, and 12 on the homework all work this same way. So heed my warning here, and when you're looking at numbers 10, 11, and 12, you should get an answer that is a fraction for numbers 10, 11, and 12. Because like I said, the whole point of this question is not can you divide two numbers and take the square root of that result. It's that, do you know how to take the square root of a fraction? Well, based on these three questions, you take the square root of a fraction by taking the square root of the numerator and the denominator. Okay, so it's just basically you can break up the square root and put a square root on the numerator, put a square root on the denominator. Okay, and you can see down here when I worked on number 15 and 16, I kind of just skipped a step. I didn't actually break it apart, but I just knew I was taking the square root of a fraction. So that's the square root of the top, square root of the bottom, which in these cases where it should have been easy because these are ones you should know from your times table. Same with 9 and 4 and 49 and 25. Okay. But then we go on to the last one. So we have 4 more questions. Okay. I will tell you, most of these work out pretty nicely, except for it's kind of a little hiccup or a little caveat that we have here is that these are actually technically, if you want to get real technical with it, these are technically three-step equations. Now, you might look at it and see, well, where are the three steps coming from? I see, like with number 17, multiplication by -4, subtracting 37. But you also got to take into account this square here, okay? Meaning, if order of operations, which we got to follow order of operations, so I'm going to write it down here at the very bottom, just so I have it referenced here, so that way we can look at it and say, what do we got to do next? So order of operations going backwards. A is being squared. That's the exponent. Then we're multiplying times -4. That's the multiplication, the m. Then we're subtracting 37. So working backwards, so going backwards, that means we need to add 37 first. So that's step one. So when we do that, the whole point there is those go away. So we get -4a squared is equal to, so it's a little tricky, -137 plus 37 is -100. And then have a lot of people that want to try to maybe take the square root here. But remember, we would be squaring, then multiplying times -4. So that means we've got to divide by -4, then take the square root. So the second step is actually divide by -4. So those go away. So we get a squared is equal to -100 divided by -4. So negatives cancel out. So we get a positive. 100 divided by 4 is 25. And the last step here, as always with all of these equations, is take the square root. So in this case, we get rid of the square. We get a is equal to plus or minus, so the negative and positive of 5. So it's actually 3 steps. 1 step, 2 step, 3 step. Add 37, divide by -4, take the square root. Okay? And that's kind of getting you into what we would consider multi-step equations where we have more than 2 steps, meaning, all right, here we specifically had 3 steps. Okay? Number 18, we're also going to have 3 steps because at the same time, we got to follow order of operations. So we have w squared, that's exponent, divide by 3, that's division, then add 21. So working backwards, that means my first step needs to be subtract 21. So that goes away. So we get w squared over 3 is equal to 48 minus 21. That is 27. Much like over here, we had w squared, or in this case, a squared times -4. Well, now we have w squared divided by 3. So w squared was the exponent, so that squared is the exponent. Then divide by 3. That means we need to multiply times 3, then take the square root. So that goes away there. W squared is equal to 81. As always, last step here, take the square root. So we get W is equal to square root of 81. Once again, we've done this maybe one or two times now. But this is one that you should know from your times tables. That's positive and -9. Okay. So all these work exactly the same. You have to follow PEMDAS, except for what makes these a little more difficult is there's one extra step. Okay. But if you follow order of operations, then the steps, it tells you what order you need to do the steps. Okay. So in this case, add 37, divide by -4, square root. Subtract 21, multiply times 3, take the square root. Without actually doing it, well, number 19, I was going to go through and do this, but this one's actually a special one in that this one looks a little tricky. But just like before, if we have something like this, we got 2 terms here, we can flip the terms around by doing our little, I guess you can call it a little box technique or something, in that, well, what has to go with the x squared? Well, it's a negative x squared or -1x squared. and then you're technically going to add to that 18 since it's a positive 18. Like I said, the sooner you know how to do this little step right here, that will make solving all sorts of types of equations so much easier for you, in that whatever the terms are, in this case we have the term x squared and we have the term 18, well, you got to look at what's in front of the term, meaning, all right, what's in front of the x squared? A negative, so that means a negative has to go with the x squared. What's in front of the 18? Well, nothing, but that means it's a positive 18, so that means it's plus 18. And now that we've written it this way, this works exactly the same as number 17 pretty much, where kind of a mixture of number 17 and 18, where we got to look. PEMDAS, so if you need to, I'm going to write it down here this time. PEMDAS tells us we need to square x first, then multiply times -1, then add 18, okay, in our equation. So that means solving the equation, we need to subtract 18, divide by -1, take the square root. So let's do it in that order. Subtract 18, -151 minus 18. A little tricky because the big negative numbers here, but if you need to, double check yourself. That's -169. Second step, divide by -1. That's positive 169 because we have a negative over a negative is a positive. 169 over 1 is 169. So the next step, take the square root. So we get x is equal to, I'm pretty sure done this one before earlier in the thing. Square root of 169 is 13. But we also have not just positive 13, but negative 13 as well. Okay. And the last one here, this is kind of a mixture. This is the hardest question by far because it's technically a 3-step equation where the answer is a fraction. Okay, well, it's not very clear to see that from just looking at it, but once again, look at number 17. Same steps apply here. We're squaring v, then multiplying times 4, then subtracting 54. So that means we need to add 54, divide by 4, then take the square root. In that order. So add 54. So we get 4v is equal to 49. Well, here's where we run into a problem because now the next step we said we have to divide by 4. Well, 49 divided by 4 gives us a decimal. And in these cases, I'm just going to be honest. I'm not looking for decimals here. I want if you need to do a fraction as an answer, leave it as a fraction because in this case, you got the decimal 12.25, okay? But at the same time, we could just simply leave it as 49 over 4 and take the square root of that fraction, okay? Because in this case, it's really easy. Oh, actually, the square would be gone at this point, so almost made a boo-boo there. But in this case, the square would be gone at that point, okay? But what would we have? We would have the square root of 49 over 4. Well, what's the square root of 49? Well, that's 7. What's the square root of 4? That's 2. So we actually have plus or minus, so positive and negative 7 halves, which you can double check this. If you went the decimal route, okay, the square root of 12.25 is positive 3.5 and negative 3.5, okay? But like I said, I'm going to specifically be, so I'll put stars by this one too. I'll specifically be looking for on the homework these questions to have fraction answers, okay? So once again, be aware of that. I want to make it very clear that the whole point of these types of questions is make sure you know how to deal with square roots of fractions. It's the square root of the top over the square root of the bottom. Okay. Now, with that being said, that's all the examples for you. As always, if you have any questions about any of these examples, you get stuck on the homework, anything like that, please let me know. And I do want to say good luck on your homework. And as always, thank you for watching.